I bought some lettuces. Let's go and plant them in my Kratky system. I will also prepare the water nutrient solution, but before doing all this, let's have a quick look at my system. Not because it is a nice system, I mean, as you can see, this system has been made with all the recycled material. But the reason why I am showing you this system, it is because it has two particularities. Let's start from the bottom. As you can see, this is an old pallet around which I made all the tank. I have wooden sides and a wooden bottom attached to the panel, to the pallet. All those legs, maybe you can see them better from this point of view. All the legs have two functions. The first function is to bear the weight of the tank itself, and the second function is to keep the walls straight. That's the reason why I have an L-shaped leg on each corner of the tank, and that's also the reason why I have a leg in the middle of the longest side of the tank, because without this leg this wall will bend due to hydrostatic pressure of the water. The system has been completed with a polyethylene food grade sheet. Actually, there are two sheets. The outer one is the working polyethylene sheet. The one which is underneath is the safety sheet. So whenever I have a little damage, a little hole on the first sheet, the second one will prevent the tank from emptying totally. I have a white polystyrol sheet for the plants, which is kept in position by this band, and I'm using plastic reinforcement to protect the angles of this white panel. Let's talk about the two particularities of this system. The first particularity is this bottom discharge point. Normally this point is closed with a cap. So when the cap is inserted, there is no water recirculation, and the tank is working like a classical Kratky system. So no water recirculation, just classical Kratky system. But if I remove the cap and if I put a bell siphon here, because this is a nipple, okay, so I can screw here a pipe and I can make a bell siphon like in the existing ebb and flow system, you see. So if I make a bell siphon, then I can transform this tank into a flood and drain system or ebb and flow. So that is particularity number one, and this is pretty useful to me because I already have an ebb and flow system over there, and by the way, it is the height of that tank over there is lower than the discharge point of this tank. So in the future what I can do is to pump the water directly from the reservoir over there to this tank. Then I will connect the discharge of this tank to the existing ebb and flow tank, and the discharge from that tank is already connected to the reservoir over there. So I can make like we call it in Italy a waterfall system. I can first fill this tank up, and when I discharge it, all the water goes over there. When it is filled up, then the bell siphon will work and it will discharge back into the reservoir. So that will be a future development, I think next year already. The second particularity is this little vessel, this little bottle. As you can see, this is connected to the main tank with a small diameter black hose. This is an overflow system. When I suck water from here and I let the water flow into this bottle, then I made a communication between those two containers. And when those two containers are communicating with each other, then also the levels will be the same in both containers. So whenever there is a height difference, whenever the level goes up or down in this tank, the level will go up and down in this tank. Here I have two holes. These are the overflow holes. So by putting these two holes, I am fixing the maximum height of water that I can have in this tank. Actually, if you look at the scale, 10, 15, 16, 17, the maximum amount of water that I can have in this tank is 17 centimeters. If it rains, the water increases, but because the two containers are communicating, the water also flows over these two holes. So the maximum amount of water in this tank is fixed. I can also modify the height of this container by just unscrewing this screw and moving the L-shape support in a higher position or in a lower position. This is useful because when it rains, if I didn't have this system, the water will increase until it arrives and submerges all the roof, and that is something that we would like to avoid. Aspetta un attimo, amore. Ok, va bene. Ok. Okay guys, I just ended the job, the preparation job. I covered the holes with some temporary solution. I will uncover the holes and put new plants in maybe 1 week or a couple of weeks. If you noticed, I have the water level at 16 centimeter, while the overflow is approximately 1 centimeter above, so it is at 17 centimeter. The water arrives at 1 centimeter from the bottom of the cup, so I have the roots which are submerged for about 1 to 3 centimeters, and I still have free space here, 2 centimeters maybe, for oxygen absorption. If you noticed, I used tap water. Tap water isn't really a good solution. It's not really it's not really a good solution, especially as far as pH stabilization regards, because it contains many carbonates and bicarbonates. And in my case I have really a lot of them, so it's not really beneficial as far as the pH stabilization is regarded. On the contrary, it is positive to have used tap water because it's more economical. I mean, with my reverse osmosis installation, my small home reverse osmosis membrane, for every liter, for every gallon of, for every part of reverse osmosis, I consume 3 to 4 additional parts of water that I just waste. So instead of consuming, this tank is approximately 160 liter, so instead of wasting approximately 600 liters, I just consumed 160 liter. At the beginning I used sulfuric acid to bring down the pH, and if you noticed, the conductivity measurement was 680 approximately at the beginning, so the tap water was approximately 680 microsiemens. After pouring the sulfuric acid, it went to 1020, 1080 microsiemens, and on top of that the nutrient solution added 1800 microsiemens more. That was the value that I really wanted in my tank, because I didn't want to work as with the tomatoes with 2500, 2200 microsiemens per centimeter. Here with the salad I wanted to be below 2000, so I just chose 1800 microsiemens per centimeter. At the beginning of the video you saw that I poured sulfuric acid. That is not 90-80% solution. It was a 10% acid solution, so that this means that the 250 milliliter of 10% acid solution actually are only 25 milliliter of acid. I don't have anything more to say. Maybe I will add something in the text below the video, and yes, what can I say, just have a nice day, and I wish you a happy growing. Bye bye, see you next time.